So the first test we're going to start off with is the TDS test. Now this test is extremely important in the beginning of our demonstration. This is what is going to set the pace for the rest of the tests and the rest of the demonstration. So how we're going to start off is by explaining to the customer the difference between rainwater and pure water, right? So I start off by explaining the TDS test to the client by saying, now this is a TDS meter. First of all, TDS stands for total dissolved solids. That's all the heavier stuff that's inside your water. This is a TDS meter. So this meter is just going to give us a numeric value for the quality of your water. So you want to think low numbers. The lower the better. If it's a high number, it's the lower the quality. The lower the number, the better the quality of your water. And I brought my own bottle of purified water to show you the difference. So you're going to take a bottle of purified water here and you're going to fill it up about right there. You don't want to fill it up too high so you drown the meter, but high enough to get right to about that line right there. Okay, and then you're going to make sure you always show the client what number are we reading. Are we reading a 0? Perfect. Then we're going to drop it in the water here. And then we're going to ask them, what are we reading? We're reading a 7, right? So that's really good, that's really low, because anything in the state of Texas under 50 is what they're considering to be good, pure. Now, I'll leave that in the water and then I'll start to explain, like when we first got these meters, we started testing everything from different waters, milk, beer, juice, wine, you name it, we were testing it. And what that did is it sparked a huge debate between me and my colleagues at work about the actual quality of our rainwater. Now, we all knew from the Earth's natural cycle of cleansing itself is through evaporation, but what we didn't know is how low or maybe how high that meter was going to read. So my friends actually went out to a gutter and they tested it, and this is what they got.
Raining outside, and I wanted to do this experiment. I want to take some water from the gutter here.
I always ask the clients, would you drink that water? Of course not.
And test it with a TDS meter. And see what we get, how pure, if the water is pure. And as you can see, the water reads at 26 parts per million, which is pretty pure. It's under 50 parts per million.
So, it reads at 26. Disgusting rainwater coming out of a metal galvanized gutter, which we think would be really high, is reading really low. So with that being said, then I'll ask my clients, if you've got our bottle of purified water here at a 7, and we've got rainwater coming out of a nasty gutter at a 26, how high do you think your tap water is going to read with that TDS meter? Most of the times they're going to say, well, somewhere in between, right? They don't think it's nearly as bad as the rainwater, but we'll take another glass and we're going to show them. So we fill up this with their regular tap water. Then we're going to take the TDS meter out, shake it off, and we're going to show the client that we're back down to 0, right? And then we're going to place it in the water. And what do we get? 338. So a stark difference between rain, bottled, and then their tap. So that's when you just explain to them that this is my job, that's what I'm here to do, is explain that number to you and what it means. And in order to do that, we move on to the next test, which is the precipitation test. Now the precipitation test is just like a luminol test for your water. And this is what you want to convey to the clients. You want to explain to them that if they don't know what luminol is, because not a lot of people do, you explain to them now, have you ever watched any crime scene shows or investigation shows? Well, most of them will say yes. Say, okay, well, when you know the cops go into a building or to a room, they know a crime's been committed, but they don't know where to start to look. They're going to spray the walls, the ceilings, the floors, everything with this chemical called luminol. When they turn off the lights and they turn on the black light, all that bodily fluid and blood and stuff will start to glow, giving them a starting point to their investigation. So that's just like this next test. It's just like a luminol test, but it's for your water. So we're not looking for any blood or guts or anything like that. We're just looking for whatever's giving us that 338 part per million reading coming out of the tap. And in order to do that, we got to use 2 chemicals. First chemical here is a potassium hydroxide. Next chemical is a hydroxyquinoline sulfate. Now when these two come together in the water, they're going to act as a glue-like substance, causing all the dissolved solids inside that water that we can't see to actually stick to each other. Then they're going to start falling out of the solution, so what we couldn't see before actually starts to become visible. So we do 10 drops of each. First we need 2 samples of water. And you always want to show the client, can you see the difference between those 2 waters? No, right? Looks like water. Well, that's why we're going to do a little CSI on it. And like I said, in order to do that, we use the 2 chemicals. Basically your luminol and your black light. So you're going to add 10 drops of each into each one of these vials. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Then you're going to move over to the hydroxyquinoline sulfate. This is your black light. 10 drops of each into each vial. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here you have it for the precipitation test. Now that's going to take a few minutes to kind of come together and do its thing. So while that's doing that, I stick this over off to the side. Keep it out of sight of the client so they forget all about it. Now the wise light is extremely important because this is going to determine, you want to ask the client, who here thinks that water conducts electricity? Okay, and some people say yes, no, whatever their answer is, and you want to kind of give them a frame of reference. So you want to ask them, when we were kids and we would be swimming in a swimming pool and a lightning storm would strike, what would our mom tell us if we were swimming in a swimming pool? She'd say, get out, right? Get out fast, because it's going to light you up. It'll light you up quick. So this is called a wise light. Then you want to say, now what would happen if that pool was free of any of those foreign chemicals, metals, minerals, or anything like that? Absolutely nothing. That's because it's a trick question. The answer is yes and no. Water in its purest form does not conduct electricity. It's only the things inside the water that causes it to conduct electricity, like the metals, the lead, the iron, all that stuff. So we're actually going to put some stuff inside this purified water, and this is moving into the gross test. Okay? So what I usually do is I'll take my finger and I'll dig into my ear, wipe my nasty fingertips up in there, make it extremely dirty. I'll take some dirt off my shoe here. Also mix that in there, and I'm pretty sure I got a dollar bill around here somewhere. Who here thinks a dollar bill is clean? Not me. So a dollar bill is about as filthy as you can get. So how many fingerprints do you think have touched this dollar bill from the year 2017 and all the way from California? So 7 years in 3 states over, how many fingertips have touched this bill? A lot. We're going to wash all those fingerprints off into this water as well. We're going to launder some money, but don't tell anybody. So, let's sit there for a second. You're going to notice the color of that water start to change, how filthy it gets, right? So, you'll ask the client, are you thirsty? Would you drink that water? You wouldn't touch that water with a 10-foot pole, and neither would I. Now, with all that stuff that you saw me put in, all those fingertips, the dirt off my shoe, the earwax, my fingertips, now how high do you think that water is going to read on the TDS meter? Was it 7, right? And most of the clients will say, oh gosh, it's going to be 500, 600. It's going to be a lot. So you'll show the client, again, that you're back down to 0 on the TDS meter, right? Then you'll stick it in the dirty water. And we're at a 65. So 65 is not that high, right? And you'll say, well, you wouldn't touch this water, right? You want to drink this water? Would you drink it? And they'll say, absolutely not. I don't blame them. But that's when you illustrate to them that they're already doing it at 338 parts per million. So way worse than that nasty gross water I just put all my fingertips and earwax and all that nasty stuff in there, right? So from there, You explain to them the reason why I contaminated this water is so I can show you how the city treats our contaminated water. We've got a really big job to do and not a lot of money to do it. So I've got a short video on a water treatment plant and its processes.
Water is a very interesting substance. It's the key to our lives. Our bodies are 90% water. 2/3 of our planet is covered with water. If it could only come out of our tap as clean as it begins in the sky. Let me show you why that doesn't happen. Water is the universal solvent. It is designed to clean. In the clouds, it's fairly pure. As it falls to the ground in droplets, the pure water dissolves and carries away whatever is in the air it passes through. Smog, chemicals, dirt, smoke. Once on the ground, the water runs down mountains, through valleys like a little magnet, picking up and carrying away a little bit of everything it touches. Agricultural waste, industrial waste, all kinds of waste. Obviously, the city winds up with some pretty polluted water to process. They don't have the money to take everything out of the water, but...
So this is when you want to get back, and now you're going to start explaining the city's water treatment process, okay? You'll ask the clients if they've ever seen anything like this over off to the side of the road, and most people have, driving past it. Now this is a water treatment plant, and what they do here is a series of tests to try and ensure that our water is as safe as possible before they give it back to us. Now how they do that is they're going to start by running all that water through a really big bed of sand and gravel. That's going to remove all the large debris, like the beer cans and cigarette butts that you saw in the video. When they're finished with that, they send it over to the first bin, and that first bin is where they do a really important process called flocculation. Flocculation is a copper powder form solution that they have to dump inside that water, and that's going to make all the suspended solids like the dirt, the rocks, the pebbles and sludge and stuff sink straight to the bottom, so that the cleaner water can move over here to the second bin. Now the second bin is where the EPA steps in. Okay, and what they're doing is they're running samples and tests based off their guidelines and their standards, and they're searching for all these different contaminants. And actually there's a book with 4 full pages of them. Once they come across these certain contaminants, that's when they're going to start identifying the different chemicals and how much of those chemicals they need to add to the water in order to just suppress the problem, right? So now in our water here, we don't have a chemical problem. We've got a bacteria problem, right? It's because I put my fingertips, my earwax, and dirt off my shoe, the dollar bill in here, right? So now when I was in the Army, I used to have to carry around iodine pills on us. Iodine pills is going to help sanitize the water, right? In case we ever came across any lakes or rivers, anything like that, we needed to be able to sanitize our water. So with a couple drops of iodine in here, you're going to see how that water or that iodine, it stays concentrated, right? See how it settles right down there at the bottom? Well, also in this second bin, they've got these really big mechanical arms with these little paddles on them, and they got to do 2 things. The first thing is they have to make sure that the entire body of water gets sanitized, right? And then next, they also have to make sure that that water is diluted in such a way that we don't get a concentrated dose coming out of the tap. It's got to be healthy for us, at least, healthy-ish. So when they're finished with that, they're going to send it over to the chlorination bin. That's the 3rd bin. And the city never forgets to chlorinate the water. They can't.
They do get the big stuff out. Cats, dogs, logs, and rocks maybe. Then they dump a bunch of chemicals, like chlorine, that are designed to kill off the worst of the bacteria.
So it's good that the city chlorinates the water. I mean, we don't want them to, but that's the only way to kill off any slime-forming bacteria. But let me ask you this. If your water came out of the tap looking like that, what are you going to do with it? Are you going to drink it? Are you going to bathe in it, brush your teeth, wash your face? No, you're not, right? And the city knows that. With just a couple drops, just a little bit of chlorine, it does 2 amazing things. 1, it's going to kill off the majority of the bacteria. And 2, most importantly, is it's going to take your water from this right here right back to that. Just like it was when it came out of the bottle. So now it's like my fingertips, the earwax, all that nasty stuff off the dollar bill wasn't even in there. But we cannot lie to the meter. So we're back at 0 right now. 148. See how it climbed? Now the difference between the 148 with all that stuff and the 338 that you got out of your tap is all this stuff right here. So this is all dissolved solids and everything that's inside your water. See how disgusting that is? This is an eye-opener for the client. They have got to see this. This really puts things in perspective. Okay? Your water, as you should be explaining to the client, should look like this. Crystal clear and clean with nothing in it, right? Now granted, when we start with your tap water, people's tap water, their tap water is sourced from open lakes, or first of all, when we start with the bottled water didn't have any chlorine or didn't have any of that bad stuff in there, right? But when we start with your tap water is sourced from open lakes, reservoirs, underground water supplies, and a portion of Texas's cleanest water comes from right here, which is the Edwards Aquifer, right? Now you can see here how the water line's a lot lower than what it used to be. And what's happening is as that water passes down the side of that mountain bed, it starts picking up all that rock and that soot and dirt and stuff and starts blending with the water. It actually becomes part of the water's chemical makeup. Then they're gonna ship it through these huge underground galvanized water pipes. Now these things are massive. These things are 8 foot in diameter. So a person 6 foot tall should have absolutely no problem standing straight up through an 8 foot tall pipe with their hands in the air, right? Now a couple of my buddies last year got to go see a portion of this pipe being replaced. When they got there, this is what they saw. This is extremely important to explain to the client. Then you want to ask them, do you think you can stand up straight in that filthy pipe right there? You couldn't even low crawl through that thing. So the problem is whatever makes it past this pipe right here is going to make it to here, which is our city's pipes. Whatever's going to make it past our city's pipes makes it to here, our home pipes. And the problem is it doesn't stop there. Everything from your refrigerator to your dishwasher, your washing machine, but especially your hot water heater is affected. Every single thing that this water touches is affected, which is the only reason why any of these appliances of ours goes out. If you had good soft conditioned water going through your pipes and your appliances, you would never have to replace them. They would never fail you. They would never have a reason to. Kind of like your shower heads. Have you guys ever seen a crusted, calcified shower head that looks like that? That's because of hard water. How about pots and pans? It does the same thing to pots and pans. We've got dirty glassware. You ever pulled the glass out of a dishwasher that still looks like that? We want our glasses and our dishes to be looking crystal clear and clean, just like that. Shower doors does the same thing. Leaves that filthy residue all over shower doors. That's called soap scum, hard water buildup. That's what happens when you introduce clean water or clean soap to dirty water. Dishwashers, the same thing. You're going to notice that buildup a lot inside the dishwashers. Okay. All this stuff is very important to convey to the client, right? So they can agree with you as far as the damage that they're seeing that their hard water is causing. Now, faucet fixtures, you're going to notice a buildup a lot more on the hot water side of things because hot water is our utility water. We absolutely use it for everything. Cooking, cleaning, showering, simply washing our hands, we're using hot water. The only thing we're using cold water for normally is to drink. All right, next we want to describe the damages done to a hot water heater, among other things, to the client to illustrate the importance of soft water, right? Now, you want to show them their energy guide. Energy guide is important because it demonstrates exactly how much, well not exactly, but a roundabout figure on how much they're going to spend annually just to run their hot water heater. Now, a hot water heater heats from the bottom up. Now, when that hard water sediment, all that limescale, all this stuff you see in this tube is settling in their hot water heater, it's very important to clean out your hot water heater every 6 to 12 months, but most people don't do it. They all forget about it. It's kind of an out of sight, out of mind. The reason being is because as that stuff is settling, your hot water heater has to heat up that limescale and that sediment, and then that limescale and sediment has to heat up the water. It's changing the way it actually heats up your water. What happens to your energy bill? Because now it's working twice as hard. it goes up. Now, because people forget about it 90% of the time, out of sight, out of mind, years go by, and it is still, what happens when you apply heat to that hard water sediment for 3 to 5 years? It turns into a rock. So now you got a condensed calcified rock sitting in the bottom of your hot water heater. So now your heater has to heat up that rock, and then the rock has to in turn heat up the water. Now what happens to your energy bill? It skyrockets. Then you'll start hearing a pinging and your hot water heater will go out. And it gets costly. So next is the soap test, and the soap test is extremely important. This is going to give the clients a visual on the difference between soft and hard water. How we do that is we're going to take 2 beakers, okay, and we're going to need 2 samples of water. So the first sample we're going to get is going to be purified water. And then the second sample is going to be hard water straight from the client's tap. You're going to want to make sure that these are as even as possible. So then you're going to want to show the client the 2 different waters. You're going to ask him, can you see any difference in these 2 waters? It looks just like water, right? So that's why we're going to add a little soap to it. So we're going to take 7 drops of soap and we're going to add it to each one of these flasks. And immediately you're going to be able to tell me which one's which. So you're going to ask them, can you see any soap in here? Right? No, it looks crystal clear and clean, just like it's supposed to look. Then you take their tap water, and now you can see the soap really good, right? Now the reason being is because the soap's first reaction is to the water itself. So before this soap can actually clean your hair, clean your clothes, clean your body, your dishes, your kids, clean anything at all, it has to clean this water first. So that's what it's doing, that's why you see it. Now, what's the first thing that you guys want to see when you mix soap and water? Bubbles, right? Soap suds. That's how we know that the soap is working. The more suds we see, the better the soap. Seeing is believing. So, we take the purified water here and we're going to shake it up really, really good. You can see lots of soap suds, right? Now, you're going to take the tap water and you're going to do the same thing. And you're going to even be able to hear the difference. And you get nothing. The reason being is because it takes 5 times the amount of soap to clean hard water. So we're going to add some more soap. I'm going to add 14 more drops to this tap water. So now we have 3 times the amount of soap. Shake it up. Still nothing. So let's add 14 more drops. Let's get us to 5 times the amount. Okay. And let's shake it up. And you still get barely anything. Like I said, it takes 5 times the amount of soap to clean hard water. Now the real question is that you want to ask the client is when you wake up in the morning, which one do you want to wash your face with? This one's crystal clear and clean, tons of soap suds. This one is filthy, funky, and dirty, and no suds at all. So, how much more money are you spending on all your soaps? Probably a lot, like 5 times the amount. Now, we also work this just like a math problem. So, if I was to take the dirty water, dirty tap water, and add it to this clean water flask, what do you think is going to happen? What it's going to do is it's going to instantly kill all these soap suds, which it did. It's just in the middle, you can't see it. So it instantly kills and dissolves all those soap suds, contaminating the water below it. Now you can see how that water below it has turned a color, a cloudy, a milky color. Now, what's left behind is you're going to get large chunks that accumulate, and that's called soap scum. That's how soap scum is developed, is by introducing dirty water to clean soap. Now, normally if this had any suds at all in it, and we took purified water and we would add it to this, it would create more bubbles and diluting and cleaning the bad water at the bottom. Next is going to be the chlorine test. The chlorine test is absolutely my personal go-to. This one is absolutely eye-opening. And what I do is I'll ask the client, now you brush your teeth with this water every day, right? They'll say yes. I'll say, okay, well, I call this next one the Man Up Challenge. So what I'm gonna do is grab 2 samples of their tap water. Now, both the same exact samples, both their glasses usually that I'll ask them if I can use 2 of their clear glasses. So there's no difference in either one of these. I'll ask the client, the man of the house normally, that's why I call it the Man Up Challenge, to take one of them, doesn't matter which one, put it back in their mouth, swish it around, and spit it back in the cup, but don't swallow it. And for training purposes, I'm gonna be that guy. So, then what I will do is I will take this is called chlorine O2O. Now what this does is this detects the presence of chlorine in the water. So if the city's doing their job and they're chlorinating the water the way that they're supposed to, when I put my solution in this untouched sample right here, it's gonna activate it and make it turn bright yellow. That's just gonna tell us that there's chlorine in the water. Now usually everywhere else I've done this, it takes 15 to 20 drops to start changing colors. Here in San Antonio, one drop instantly changes yellow. Keep in mind, the faster it changes, the more yellow it gets, the more chlorine that's inside the water. So you ask the client, what color do you think that this one should turn when I put my solution in there? And it should turn yellow. It's the same sample. Let's check it out. But it doesn't change. So where did all that chlorine go? So with that one swish, that fast, all that chlorine that was inside of that glass stayed absorbed inside of my mouth. And when I spit that water out, I actually spit it out cleaner than it was when it went in. I filtered that water. And the same thing happens every single day that we shower. We bathe, we brush our teeth, we wash our face. Our skin is the largest organ with millions and millions of pores. So all those contaminants, all this chlorine comes out of that faucet, hits our bodies, absorbs inside of our bodies, and then we send the water back down the drain clean. We're filtering the city's water. We're gonna move into the hand washing test. And the hand washing test is the last test that's extremely important. Not only can the clients be able to hear and see what we're talking about, but now they're gonna be able to get to feel it. Now, what I do is I have my mini refiner I hook up to the sink. We've got some antibacterial soap right here, right? So we're gonna have the clients get their hands nice and wet, right? And have them pump some soap inside of their hand and lather up really, really good. Okay. Now you're gonna ask the client to rinse off their right hand with this good, soft, purified water. And they're gonna notice the slickness, the softness. And what that is that's the actual oils in your skin, it's actually activating the natural oils inside your skin that make your skin feel extremely silky, smooth, and soft. Kind of feels like the soap's not being rinsed off thoroughly, right? But the soap is meant to glide completely off. Then you're gonna have the client smell their hand. and when they smell their hand, smell absolutely nothing, right? So then you're going to shut this off. So then you're going to have the client rinse their other hand with their tap water. You're going to notice the dryness and the squeaky cleanness. Now we always associate the squeaky clean with cleanliness, right? But unfortunately that's the exact opposite, because I'll have them smell their hand and they smell tons of soap. And the reason being is because the soap is not being rinsed thoroughly. It's another contributor to the dry skin, to the itchiness, and all that bad stuff, okay? Now, that is all of the tests, but what you want to do is you want to ask the clients questions. You want to find out if they have any questions. You want to explain to them that your job is to take their water from this right here to this right here without even affecting their monthly budget. And if you could do that, do they think that would benefit them and their family? How could it not?